Hello everyone. Welcome to the stream. Today we're going to continue going through the Rust book to learn the Rust programming language. So I will be going through chapter 2, which is about creating a guessing game. Okay, so let's see. In this chapter, we're going to create a hands-on project. And we are going to see some common Rust concepts, learn about let, match, methods. So, okay. So first we're going to create a new cargo project. I'm going to name it with the chapter number instead of what it says here. And we can check the cargo tunnel. And the main file contains the hello world, and everything is working as expected. Okay, so first we're going to get the input from the user, and that's using the standard IO module and the standard in readline. Okay, so I will type this out. I will do it manually instead of copy pasting so that I get muscle memory. That's what works best for me anyway. So we prompt the user for the input. And here we're declaring a variable, a mute variable of type string. All right. And then we use the module that we imported. Hi, the real beep random. Welcome to the stream. I think you're the first viewer. So we read a line from the standard in, and we store it in the guess variable. And then we just print it out. And here it's explaining line by line what the code does. So yes, first we are importing the IO library. There are some things imported by default on every program, and that's called the prelude. Well, I'm going to focus on this. Then we declare the main function, which is the entry point. We print out some messages. We declare a variable. So this is similar to JavaScript, where we use let to declare variables. And we don't need to specify the type. So I guess it infers it from what you are passing in. Mm, And they are immutable by default. Okay, so we can have mute or not. Mm, Okay, let's try to run it and see if it works. Okay, I can type my input and it works. So yeah, here basically it explains what this function does, but I think it's pretty much self-explanatory. Basically, it reads from standard in and puts it into a string. Yeah, and since we are modifying the string, that's why the guess variable was specified as mutable. Also, yeah, this is like references in C++. So we use the ampersand to specify that this is a reference. That way we don't need to copy. Yeah, and I think reference have a lot to do with the borrow checker, which I have heard a lot of, but I will guess we will see it later on. Yeah, in chapter 4 we will go more in depth over references. So yeah, let's continue for now. Mm, Expect. So after we read the line, we are calling expect. Yeah, and we could have put it in a single line. So read line, it returns an IO result. What is an IO result? Hmm? And here we have a similar example. So the result is an enumeration. And we will cover enums in chapter 6. And here we use it for error handling, okay. We can have variants okay or error. Yeah, so I guess this read line can fail and it returns basically whether it failed or not as an okay or error return value. And the result type has an expect method. Okay, so we are calling, yeah. So this returns a result. I will add some comments. So this returns a result, IO result. And what's the signature of the expect? Yeah, expect will cause the program to crash and display a message. Yeah, in this case, if I'm not sure how I could make this fail because if we cannot read from standard in, that means that something very wrong is going on, but okay. And if it's okay, then we get the result back. Mm, let's try what they are doing here. So they say that if we don't do this expect, we should get a warning. So yeah, it says that an unused result must be used. But it's still compiled and it ran correctly, so it's just a warning. But let's put it back so we don't get the warning. Yeah, and in chapter 9 we will go more in depth in error handling. Okay, and the final line is where we print the input that we got from the user. Yeah, and this is like some kind of string interpolation. We can put values and then after the string format we specify the parameters. Okay, let's continue. Next we need to generate a secret number that the user will try to guess. The secret number should be different every time so the game is fun to play. So how do we generate a random number? Rust doesn't yet include a random number. However, it does provide a rand crate. So I guess we're going to use a library or crate, as they call it. It's a library crate. And we need to specify it on the cargo toml. Okay. And where do we put it? Beneath dependencies. Makes sense. So run and the version number. Here they explain semantic versioning. Okay. And then, okay, so semantic versioning. So we can get any version 0.8 and the patch can increase, but if we want 9.0, we need to specify it manually because the API is not guaranteed to have the same API. Okay. So, if I run cargo build on this, it's updating, it's grabbing these dependencies. Okay, we got the rand crate as well as some other dependencies of rand, I guess. Hmm. And if I run cargo build again, okay, yeah, it doesn't do it again. And now it has created the cargo lock. Okay, I'm going to skim over this because just how to manage dependencies. Yeah, and we will go more in depth again in chapter 14, so I won't worry too much about this. I will go to the next section to see how we use this rand crate. So let's again open the source file and we need to import this RNG and then we call thread RNG get range. Okay, so RNG it's a trait and we need to have it in scope to use some methods and we will cover traits in chapter 10. Okay, everything they introduce we're going to cover it later on but I guess we are still in the early stages, so that's usual. And then we add this so from the rand crate we call the thread RNG method and that get gen range from 1 to 101. Not sure if it's inclusive or not. And then we print what we get. I'm gonna run it directly. Okay, so we got 55, 74, okay, 55 again, 75, okay, seems to be random. Yeah, here we get a random generator from the thread local storage, from the current thread. And this method is defined by the RNG trait. Okay. And then we call gen range on it, which takes a range expression. This range goes from start to end and is inclusive but exclusive on the upper bound. Okay, so we will get between 1 and 100. Okay. And we could also use this syntax to specify. I'm going to use this syntax, I think. It's more clear. So from 1 to 100, both included. Yeah, and here, basically here they know that we need this, but if you were using a library which you don't know, then how do you know that you need to use this trait? I guess from the documentation. Okay, so we generate the number. We are showing it now for debugging purposes. And then we get a guess from the user and we print it also. And then we use this match new syntax and we compare it. I'm gonna type it out and I will read it, the explanation later. Yeah, and we need to import this type on the top. Ordering is an enum which has three variants: less, greater, and equal, which are the possible values that you get when you compare. And we can call compare on anything that can be compared. And we use a match expression to decide what to do next based on which variant of ordering we get. So it's like a switch statement, more or less. This returns an enumeration which has these three variants. So depending on which one, then we will print one of these three messages. And the expression is made up of arms, and an arm consists of a pattern to match, and the code that should run if the value matches the pattern. Let's see if I can run this. we get errors. Ah, yeah, and on the first chapter they explain that when we have these drawings, these images, it means that it won't compile. But let's see what the errors are. So secret number doesn't have a type. Yeah, it looks like, and also expected string found integer. Well, let's continue reading, but yeah, guess is a string, and we are comparing it with secret number. So I guess the guess and secret number must be of the same type. So and secret number we will probably have to specify the type or convert it or something. Let's continue reading. Here it's still talking about the comparison. Yeah, and here they do get the same error. So I guess we infer that that should be a string, and secret number on the other hand is a number. And it doesn't know what type of number. It can be 32-bit, signed, unsigned, or 64-bit, and others. By default, it will be I32. And we cannot compare a string and a number. Yeah. So we are going to convert the string into a real number. How do we do that? So it's declaring a variable with the same name, and then trimming the string, parsing it, and then calling expect like here. Let's type it out. Here we are specific about the type instead of using type inference. So we call trim, parse, then expect, please type a number. Yeah, so it looks like we can shadow variables because we already had a guess variable, and here we are declaring a new one with the same name, and that shadows the previous one. Yeah, that's what you normally do. You use a different name for these kind of situations. Okay. Yeah, and that I can see why that's useful when converting a string to a number in this case. And then we call trim and parse. The trim will eliminate white space. So we get rid of the new lines and extra spaces, okay. And then we call parse, which is a method of strings, which parses it into some kind of number. And we tell the type we want to parse into. Yeah, that's why we specify the U32. Because we can parse other kind of numbers, I guess. Mm. So now guess will be U32. And we compare guess with secret number. Therefore, secret number should be U32 as well. I see, I see. Yeah, and parse can fail if you don't, if the string is not a number, it will fail. So that's why we have also this expect, because yeah, parse returns one of these result types. Okay, let's try to run it. Let's try to run it here. Okay, I type a number which is smaller and I get small. If I type a bigger number, it's bigger. And if I type the same number, then you win. And if I type something that is not a number, we get a panic. But yeah, and we get this line number, line 20, which is in the expect. Okay. So we are almost done, I think. Yeah, we just need to loop to let the user type more than one number. And we use loop, the loop keyword. So in here, we start the loop and we close it here. I think there's a, yeah. So now we are looping, we print, please input your guess, we read the input, and we compare it with the number that we generated at the beginning. So I can type 1, it's too small, 50, it's too big, 25, too small. Yeah, and we can do the typical binary search now, but since I know the solution, I can type it directly. Okay. Yeah, and this loop will run forever, so we need a way to quit now. We could use Control C, but that's not very elegant. Or also, yeah, if we type the user enters something that's not a number, we will panic and we will crash. Yeah, you could even type quit, but it will crash with everything that is not a number. Okay, so first we will quit. Yeah, because even when I won, still wants input. So first thing first is to when we when we get the right number, we should break out of the loop. So that's easy to do. We just print the same message, but then break out of the loop. So now we will not run forever, just until we win. But also we can handle invalid input. So we're going to ignore when the user types something that is not a number. How do we do that? Okay, so we read the line and then instead of expect we use a match statement. Okay. So we match on guess. And we can have two different possibilities here. Either we get okay or we get an error. And in the case of error, we just continue. And in the case of okay, we just get the number back. Yeah, so this is similar to what we were doing with the compare. And if we are not able to convert the string into a number, we will get the error. But instead of crashing, we will continue to the end of the loop so that it will go to the next iteration. The underscore is to match everything. Yeah, so now it should work. So can input a few options. If we type something which is not a number, we don't crash. We just prompt the user for more input. And if we guess the right number, we also break out of the loop. Okay. So yeah, the only thing left to do is to remove printing of the secret number. That should be pretty easy. We just remove this line And that should be all, I think. Okay, congratulations. In the next chapters, we will see these concepts in more detail, I guess. It says here. Chapter 4 is about ownership, 5 about structs, and 6 about enums. Let me run the program one more time. Now we don't get the help. So 50 is too small. 75. 58. Whoa. One more. 50. 75. Too big. Guess 90. 89. Yes. Okay, so we completed chapter 2. And I have to go actually. So thank you for watching, and I will see you next time.